Okay, let's move on to example number 4. Example number 4 says, find all zeros of x to the 5th minus 3x to the 4th minus 5x cubed plus 5x squared minus 6x plus 8 and linear factorization. Okay, so this came up during the test, right? We'll say, well, I have so many, what are the possible roots here? What are the possible solutions that I have? I have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. 1, 2, 3, 4. So I have 8 different ones that I can try here, right? So rather than just going arbitrarily starting and just going on from here and just guessing, I can actually use my calculator, graph it, and find the ones that I know, right? So if I use my calculator and I find out that I have 1, -2, and 4 are roots. So I have 3 other roots, right? So how many roots are there together? How many solutions are there? There are 5, right? So I'm given 3 of the 5 roots, okay? So let's see what's left off when I'm done, right? So I have, so let's go ahead and actually 1, -2, 4. Let's go ahead and do the synthetic division and see what I have left over once I'm all done. So I'm gonna have 1, -3, -5, plus 5, minus 6, 8. Okay, so the first one is 1, so let's do 1, 1, 1, -2. -2 times 1 is -2, -7. -7 times 5 is -2. -2, -8. 1 times -8 is -8, 0. Okay, so we use that one. Then I'm going to use 4. Let's use 4. 1, 4, 2, 8, 1. 4 times 1 is 4. 2 times 4 is 8, 0. Okay. So then I'm going to use -2. So let's do -2 here. Actually, you guys are used to seeing it this way. So let's go ahead and do it this way. -2, 1, -2, 0, 0, 1, -2, 0. Okay, so in the end, what do I have left? I have this left, right? So what is this? This is just the one, the constant. This is the x term. This is the x squared term, right? So what I have left at the end is what? X squared plus 1, right? So I can rewrite this. And I know that after I'm using these 3, I'm going to have x squared plus 1 left over, right? So this is basically going to be, the rewrite is going to look like this. The rewrite is that I know that I have x minus 1, x plus 2, x minus 4. And what I have left over is this. Okay, so I know the root for this, this, and this. I just need to find the 2 roots here. What is it going to be? X squared plus 1 is equal to 0. So x squared is equal to -1. X is equal to plus or minus I, right? So my other 2 roots are plus or minus I, okay? And write it in its linear factorization form. So basically, I'm going to have to rewrite this in a linear factorization form, x minus 1, x plus 2, x minus 4, x minus I, x plus I. So that would be the final answer. Okay. So you have to go all the way down to this. Okay. Now let's do number 5. Example number 5. The complex number 1 minus 2i is a 0 of the following function. Find the remaining zeros of f of x and write it in linear factorization form. So the actual equation is x to the 4th plus, oh, it's 4x to the 4th, 17x squared plus 14x plus 65. And I know that one of the answers is this, which means that I also know that this guy is an answer too, okay? Now the book has you go through actually doing the synthetic division using complex numbers. Now that's very complicated, okay? So instead of doing that, I want you to read that. So you should read that and still understand how they did it. But I'm going to teach you a different way to do this, okay? So since this is a root and this is a root, I know that this is going to be equal to x minus 1 minus 2i, x minus 1 plus 2i, and then there's something else here, okay? I don't know what this something else is yet, okay? I don't know what's left over. But I do know it's going to start with 4x squared. Does anybody know why I know that? Because I have x squared here, right? And I know that the leading coefficient is 4x to the 4th, which means it's going to have to be 4x squared something, something, something here, right? I don't know what this is yet. I'm going to try to find this, okay? In order to find this, I'm going to do this out first. Okay, so let's do this out first and see what I get. X squared. And then I'm going to get this guy, so it's going to be negative 1 minus 2ix. I get this guy, so it's going to be negative 1 plus 2ix, negative 1 plus 2i, negative 1 minus 2i. When I add these two together, it cancels out. I get negative 2x. Okay, and then I'm going to have to do the constant part, which is this guy times this guy. So I'm going to get what? 1 minus 2i. It's a negative. The negative cancels out. 1 plus 2i. So I get 1. Then I'm going to get 1. And then I'm going to get negative 2i plus 2i cancels out. I get negative 4i squared. Negative 4i squared is basically plus 4. So 1 plus 4 is 5. And then I'm going to get 4x squared plus something, something, something. I don't know what it is. Okay? So I can go ahead and divide this guy by this guy, right? And it should factor out. There should be the remainder of 0. Okay, so let's go back to the old-fashioned. We're just going to go ahead and do, the long division. Okay, so you get x squared minus 2x plus 5, dividing this into 4x to the 4th. Okay, there's no x cubed, so I'm going to leave that there, the placeholder. Okay, so I'm going to multiply this to get this. I need 4x squared. 4x squared minus 8x cubed plus 20x squared. Subtract it out, I get 8x cubed minus 3x squared plus 14x. To get 8x cubed, I have to multiply this by 8x. 8x cubed minus 16x squared plus 40x. Now let's go ahead and do the subtraction. If I subtract this out, I get 13x squared minus 26x plus 65. To get to 13x squared, I have to know it's going to be 13. So I get 13x squared. 13 times negative 2 is negative 26. 13 times 5 is 65. And ding, 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 we have a winner. There's a 0 remainder. Okay? So in other words, this guy here is this times this. Okay? So I can rewrite this as this guy times x squared minus 2x plus 5. Okay, you will find that this is actually easier than what the book is trying to teach you how to do on the doing the complex numbers, using the complex numbers, doing a synthetic division. Okay, so from this part, I got these two. So I just need to go ahead and find here, right? So what do I have here? So this is actually going to be what? I don't know. Does this, okay, this does not factor out. Does not factor out. So we're immediately going to go into the quadratic formula, right? So the quadratic formula. From the quadratic formula, I'm going to get two roots here. And they're going to be what? 2a minus b plus or minus square root of b squared minus 4 times a times c. Okay, if I do that, I'm going to get negative 8 plus or minus 8 on the bottom. I get 64 here. I get 16 times 13. So it's going to be 208. So 64 minus 208. 64 minus 208 is going to be what? 144, looks like. Negative 144. Something like that. 144 is familiar. That's 12 squared. So I'm going to get negative 8 plus or minus 12i 8. Divide everything by 4. I get 4 negative what? This is going to be minus 8 over 8 plus or minus 12 over 8i. Negative 1 plus or minus 3 over 2. 3 over 2. I. Okay, so these are the other two. Okay, so you have this guy, these two here, and these two here. Okay, and what the question asks for, it says, write it in its linear factorization form. So if I write this, rewrite this in a linear factorization form, I'm going to get what? I'm going to get x minus 1 plus 2i. I'm going to get x minus 1 minus over 2i. Then from here, I'm going to get x minus 1 minus 2i times x plus, no, x minus. Okay. Now, here's something that's fairly important. If I leave it at this, I am technically incorrect. Okay, the reason why I'm incorrect is because if I did this out, what do I get? I get this times this times this times this to get the x to the fourth terms, and it'll be just a 1, whereas it should be 4. So I'm missing the 4 here, okay? So the clue to where I'm missing to the 4 are here and here, okay? So if I take that 4 and I divide, if I go ahead and multiply this guy by 2 and this guy here by 2. Okay, so basically what I'm saying is that 2 like that. If I divvy up the 4 and I go 2 and 2 here, then these guys will go away. So I'm going to get what? 2x minus 2 plus 3i. I just did the 2 out here, 2 in there, the 2 in here. Okay, they're going to do something with this 2 here. 2x minus 2 minus 3i. Okay, and then I'm going to, this guy just carries down. Okay, so blah, 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 blah. So if you look at the bottom, very bottom of page 213, we arrived to the same conclusion, okay, and in my mind, in a cleaner way. Okay, all right. Factoring with real number coefficients. Okay, flip the page on 214. There's a green and blue box in the middle. Every polynomial function with real coefficients can be written as a product of linear factors and irreducible quadratic factors, okay, with real coefficients. And this is right here, right? This is an irreducible quadratic factor, such as this. This is also an irreducible quadratic factor. Okay, so let's see if we can do that. Let's see if we can use, we're going to do example number 6 and see how this works. Example number 6, write that as a product of linear and irreducible quadratic factors with each real coefficient. Okay, so I have f of x is equal to 3x to the 5th minus 2x to the 4th plus 6x cubed minus 4x squared minus 24x plus 16. Okay, so what are my possible factors here? There are quite a few of them. Namely 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20 of them. There are 20 possible ones, right? So again, and I don't want to go through all this and figure it out. Actually, you know what? This one here, if you look carefully, I have 3 minus 2, which is 1, plus 6 is plus 7, minus 3. That doesn't work either. So they don't add together because they don't add together either. Okay. All right. So I would go ahead and put it in my calculator. Find out if there are any ones that immediately pop up. And if I do that, I will find. Are there any ones that come up? Okay, it's 2 over 3. So 2 over 3 comes up as 1. So I get 2 over 3, 2/3 being one of the solutions. Okay, so let's do the synthetic division here. Three comes down. This times 3 is 2, 0, 0, 6. 6 times this is going to be what? 4, 0, 0, negative 24. Negative 24 times this is going to be negative 16. And indeed, it is a 0. Okay, so what do we have left? We have this guy left. So this is going to be the constant x, x squared, x cubed, and x to the 4th term. So if I rewrite this, I can rewrite this as what? I can rewrite this as x minus 2 over 3, 3, x to the 4th, plus 6x squared minus 24 is right there, okay? So this is what this looks like, okay? Okay. So, I don't want this fact, I don't like this here, so I'm gonna go ahead and bring the 3 out of here and multiply it to here. So I'm going to go, this is x minus 2/3. I don't want the fraction. So I'm going to pull the 3 out here. If I pull the 3 out here, I get x to the 4th plus 2x squared minus 8. Now I can multiply this 3 into here. I'm going to get 3x minus 2, x to the 4th. So what do we have left here? I have that's the 4th equation, but it also kind of looks like in a quadratic form, right? In other words, if we just look at this guy here, x to the 4th plus 2x squared minus 8, if I call x squared the large x, this is really large x squared plus 2x minus 8, which is definitely a quadratic form. Not only is it a quadratic form, it's a quadratic form that factors. Right? It factors like this. Okay. So I put the x back in, I'm going to get x squared plus 4, x squared minus 2. And this is fairly good for us, right? Because now I can rewrite this thing here as x squared plus 4, x squared minus 2. Okay, so from here, it's a simple 3x minus 2. This guy here is going to be what? X plus root 2, x minus root 2. That's for this guy. This guy here is going to be 2i, right? Okay. So actually, what does it say? It says product of linear and irreducible quadratic factors. Okay, so we would leave this guy as irreducible quadratic factor, right? Whereas these guys are all real roots, so you just can leave them as they are. Okay, that's it. And on the very bottom of page 214, there's a blue box there that says, every polynomial function of odd degree with real coefficients has at least one real zero. Okay, well, yeah, that makes sense. We actually discussed we talked about this in the intermediate value theorem, right? We said that since it goes from here all the way down to here, there would be somewhere it has to cross the 0, okay? So we already talked about this. We already know this. All right, we're done. Okay, so